So now the last thing I want to do today is I want to show you how to derive the three equations of motion using what we have learned, but using a projectile. Remember when we derived the first equation of motion, we did it on a straight line? Then we did it when things were moving in a circle. Now let's try to derive them when we have a projectile motion in 3D. That is exciting. Do you guys want to see the three equations of motion being derived?
Sure.
The first time I saw this, I was so excited. I was like, this is so cool. I don't know. I'm easily amused, apparently. Like this. Just to make our life easier, let's just say its initial velocity is v0 and its angle is theta. So suppose its initial velocity is 0. And the angle is theta. So what will its acceleration be? I'm just going to call this x and y, just for simplicity's sake. Ax is 0, and ay is always minus g. That's what we know, right? Will that remain true anywhere in the projectile? Yes. I have seen students make this mistake where they will be like, oh, velocity at the top is 0, so that means acceleration should also be 0. And that's not true. Acceleration will always, always, always be negative g because it's being pulled downwards, 9.8. And its ax will always be, no matter where we are. Ax equals 0 implies v is a? Okay. So now let's try to derive our equations of motion. So first of all, I'm going to say, okay, what will I get if I want to find the velocity of the projectile? May I write Newton's laws, sigma F equals minus mg and sigma Fx equals 0? Is this equals to mx double dot? And does this equal my double dot? We just did that, right? So this means I can write mx double dot equals 0 and my double dot equals minus mg. If I combine all of those equations of motion, can I write them in terms of r? Just x, y, z's, combine them together, write them in terms of r. So may I write this as mr double dot equals minus mg? May I get rid of the m's? May I write this r as v? So may I write this as dv over dt equals minus g? Yes?
Where did v equals x times t come from?
Yeah, ignore that. So you're right. This should be x equals vxt. Yeah, that was me writing it wrong. Okay, so far so good? Do I do vt equals minus g delta t? May I integrate both sides? From some v0 to some v and from some 0 to t. What do I get? Or what does that look like?
Rectangles. There we go.
Okay, now do you want to develop the second one?
No.
Come on, it's fun. Okay, so the second one will be displacement. And it's not even I'm looking for those equations of motion, I'm just doing displacements and stuff, right? If I wanted to find the displacement of a projectile, can I do this? V equals V0 minus GT. Is this dr over dt equals V0 minus GT? Is this dr equals V0 dt minus GT dt? Integrate. What do you get?
Another
Delta R equals V0 T minus G a half GT squared.
Good guess.
I know. Act surprised, shocked.
completely dumbfounded. My jaw.
Speed of a projectile.
I want to be more.
It's the same thing, Amanda. We're not doing anything new. So speed is a scalar.
Yeah,
Can I use energies?
Yeah.
sure.
Okay. May I use delta E equals 0?
Why not?
Okay. So what is delta E? E final minus E initial
Yeah,
equals 0,
yeah.
which means it is T final plus U final minus T initial plus U initial.
Yeah,
1/2 mvf squared plus mgy, whatever y may be, minus what was the initial t, 1/2 mv0 squared.
Yeah.
What was the initial potential?
Nothing.
Nothing. So may I write this as m's all go away, right? So I'm not even going to worry about them. Okay, what will I get? Okay. 1/2 v naught squared. So do you see something happening? If I take 1/2 common out, what am I left with? Or what equation is this one?
it's very equation.
Do you see these magic happening? Look at this magic. Isn't it pretty?
It's very organized.